Good afternoon, everyone, and thanks to the organization for having accepted our presentation. It's a use case from Portugal about administrative boundaries. So my name is Giovanni. I'm Italian, but I live and work in Portugal since long. Actually, I'm a wildlife biologist by trade. I at some point changed my career to GIS. I co-founded a company called Natural GIS. We were very early QGIS adopter, 2008, 2009, so long time ago. We are sustaining members. We have organized a couple of developer meetings in the past years in Lisbon and in Madeira. What we do, it is the usual stuff around QGIS. So we make QGIS the core of our business, and we do support, development, hosting, training. And training we do quite a lot. We used to do more, but we still do quite a lot. And actually, we have been able to contribute to QGIS a lot back through the certification program. Someone may know my name or not. I was the most active user on QGIS Tracker for a long time. Not anymore since 2022, but I'm planning a comeback, maybe. Let's see. We are located in the south of Portugal, in Évora, in what, in my opinion, it is the most beautiful place in Portugal. It's called a region called Alentejo. And as this presentation is about administrative boundaries, it's kind of boring. I decided to put here a small trivia with an answer at the end of the presentation. And the trivia is, you know why in many maps, official maps in Portugal, a piece of boundary is actually missing? Well, the answer to the end. So I have to thank a few persons, my colleagues, Alexandre and Alexander, that actually they did the bulk of the work I'm presenting. And a few people in an entity called the Direção Geral do Território. It is General Directory for Territory. That is the entity that committed to ask it to do this job. This is the official Portuguese entity that oversees territorial planning, geographic information, cadastral and land information, and many other things. And fortunately, in recent years, they became big open source and open formats promoters and adopters. Not entirely yet. Hopefully, also the persons and the departments that they still use closed source software, GIS software, they will move on in the next future, but it's a slow process. So this entity, as many others in Portugal, I should say, many times they rely on outsourcing when it comes to get some work done. Lack of human resources, lack of other means. So frequently they do public tenders to look to get something done. And in late 2023, so they opened a public tender about creating this new data model for administrative boundaries, and well, we got it. It was really not a very big tender, but regardless. So in this tender was asked to create this new data model, including mainland Portugal, but also Azores and Madeira archipelagos. It had to be based on PostgIS and had to be ready to produce outputs for the following the inspired directives and also the Euro boundary map model. What they had before, so they had a model that it was based on proprietary software and formats, and the model was not really good. So it had a lot of problems. One of them is that the history of changes of the boundaries and the reason for changes was not part of the model, and it was actually, this list was stored in an Excel file. They had no mechanism mechanism or tools to validate the results, and the GIS software they were using, it was not handling very well topology, the needed topological relation needed in such a model. So if you go on their site and you grab an old version of the boundaries map and you do a dissolve, it is not infrequent to get bad things like the one you can see on the right. So all kind of overlaps or slivers between administrative units. So speaking about them, in Portugal, the smallest administrative unit, it's called freguesias, it's parish, okay? And then, of course, from there, you can get bigger administrative units that are municipalities and districts. Then there are also the NUTS, 3, 2, and level 3, 2, and 1, where the NUTS 3, for some reason, it is not directly derivating from districts 1. So what are the changes so of this boundary map? It is produced one version each year, one official version, and what are the changes that happen between one year and the other? Well, the more frequent one are aggregation of parishes and disaggregation of parishes, and as well as a change in what it is the shape of a boundary of part of a boundary. So what they asked for a set of script, tools, and function for handling the changes, for generating the outputs. They wanted something to keep track of history, of the changes. This new data model had to fit another data model about cartography that they already have, that it is already based on PostgIS. And then, of course, they asked to document all aspects of this new model and everything that has been built around it. In the tender, interesting fun fact, there was no site of the word QGIS anywhere, but it was assumed that it was a de facto choice to use QGIS as a desktop platform to manage, handle this new data model and generate the outputs and anything else. At the same time, it was required the heavy lifting, so the actual computations and generation of outputs and validation to be done on the database side, so on PostgIS. So why they wanted the data model and the tools deduplicated from desktop JS, so they wanted to be sure that if some fix had to be done, it could be done directly into the database, the function, the triggers in the database, and all the computation it was had to be done on the server side. So relying also on the hardware where the database server is installed, with no need to publish new version of, I don't know, a QGIS plugin. So what have we done? We designed the new data model so that everything was in a real relational data model. We implemented everything using SQL code, basically, to create table views, function triggers, and everything that is needed. We implemented triggers to store the data before any change, so to create a history, and also functions to recover data at a specific point in time. And then also implemented scripts and routines and functions to generate the necessary outputs. This is a very simplified view of the data model. It is missing a lot of stuff like domain tables and other things, but this is just to give an idea. So the core of the data model, well, it's not super simple, but also not overly complicated. From a geometry point of view, the data model for boundaries, it is similar to other data models of this type. So it is made by edges, nodes, and centroids, okay, where it is the centroid that holds the bulk of the information associated with a specific administrative unit. So we created this data model, all these tables. We had to handle a few different coordinate reference systems because Portugal mainland has one, Madeira has one, Azores have two because it's a very large archipelago. We created function to generate outputs that accept a CRES or time as a parameter, so to produce output with a specific CRES and at a specific point in time. So the pipeline it is the pipeline that generates the output. It's relatively simple. So edges are turned into polygons. Then the information is crossed with the one that it is stored in centroids. At this level, every polygon, it is a separate entity, so exclaves, islands are still separate from their main polygon, so then we make everything multi-part as it has to be. Then there is an update process of the information associated with the edges, and then there are the script and routines that generate the output. On the validation point of view, we created a number of views that store in real time, because our views, information about if find errors like invalid geometries, duplicate centroids, duplicate edges, crossing edges, and other types of errors. So these views must be all empty to be sure that everything is it's okay. On the QGIS side of things, we created project with styling, relation forms. Everything is stored into the database. And so this is a screenshot of how one of these projects look like. There's a lot of tables, and there is of course, the project and the layers have their proper forms with relations to allow to navigate the data and handle the data. We had so everything runs in the database, and to allows the user to run tasks from within QGIS, we created a processing extension. So it is quite nice because it's quite easy to create a nice user interface to allow runs routines on a remote database. We had to also, at that time, we have to also to create a custom digitizing tools that allow it to cut edges and at the same time keep the ID of the original edge to be possible to store it in the history table. Probably this is something that in recent version of QGIS you can do it by default, but at that time this was not yet available, so we had also to create this tool, and at the same time the tool allows to the user to describe why this change is being done. Okay, and about 6,000 lines of SQL and about 800 lines of Python and documentation after the work was done. It is public, in a public repository. So everything is open. It's nice to see public administration, in this case, pretty big ones, to use open formats and software. It is open to contribution. It's nice to see, again, it's not the first time and not the last where it can be showcased how good PostgIS and QGIS work together. And so basically a win-win situation for everyone. So the answer to the trivia. So there is a Spanish/Portuguese city right on the right of the border, and that spot, it's called Olivença. It was Portuguese until 1297, then returned to Portugal in 1815. On paper, actually, it was never really returned to Portugal, to the point that officially Portugal in that place do not recognize the border. So if you grab a topographic map, for instance, you see that the symbols that defines the international border that crosses along that river, at some point they stop to show. Still, they are not killing each other for a piece of land. Thank you.
Thank you very much.